Example 11.1 says evaluate the determinant of each of the following matrices. So we'll notice here that in part A we have a 2 by 2 matrix, and that means it qualifies as being a square matrix, so we can certainly take the determinant of that. So I'm going to indicate that I want to take the determinant of this matrix by rewriting the entries and then using my notation to indicate determinant of. So to take the determinant, the formula says I'm going to take the 1, 1 entry, multiply it by the 2, 2 entry, so that's 7 times negative 5, and then I'm going to subtract the product of the 1, 2 entry with the 2, 1 entry. So I'll be subtracting 9 times negative 2. So use all your arithmetic skills and perform the products first. That'll be negative 35 minus negative 18, which is going to become negative 17. And that is a real number that we call the determinant of the matrix. And this particular real number is associated specifically with this matrix right here. So if I have a different matrix, then there is going to be another real number that is specifically devoted to that matrix. So each matrix will have its own determinant calculation. Part B, we're going to practice this again. Part B, we have the entries 2/3, 1/3, negative 1/2, and 3/4. And I want to take the determinant of this matrix. So again, following the pattern, the formula says we would take 2/3 times 3/4 and subtract from that 1/3 times negative 1/2. So take your time with this. Make sure that you understand the fractions and how they all come together. So here we would want to take 2/3 and multiply it by 3/4. So with this multiplication, we're going to recognize that we have common factors of 3, 1 in the numerator, 1 in the denominator. They can cancel. And 2 over 4, 2 will go into 4 twice, and it will go into 2 once. So 2/3 times 3/4 is really just equivalent to 1/2. And then 1/3 times negative 1/2 is just going to be negative 1/6. So you just multiply across the top, multiply across the bottom there. And I'm not crazy about looking at this as a subtraction of a negative number. So I'm going to write it as 1/2 plus 1/6. But I can't do that addition either because I don't have a common denominator. So we'll get a common denominator here, multiply top and bottom by 3. That's going to result in 3/6 plus 1/6. And adding the numerators, keeping the common denominator, 3 plus 1 gives me 4/6. And we would always reduce if possible. In this case we can, and that gives us 2/3. So 2/3 is the real number that is associated with the matrix that we were given. This is called the determinant of the matrix.